Okay, Assalamualaikum and good day everyone. So let's see the example on finding the eigenvalues, eigenvector and also normal eigenvector. So before this we have learned on how to find the eigenvalues. Then from eigenvalues we will find the corresponding eigenvector and also the normal eigenvector. Okay, so now let's see how to find the eigenvalues, eigenvector and normal eigenvector of the following matrices where you have A equal to 2 times 2 matrix 2, 3, 4 and 1. Okay, so now question asks you to find three things. The first thing is the eigenvalue. Then you can find the eigenvector corresponding to the eigenvalue and also the normal eigenvector. Okay, so let's start on finding the eigenvalue. So we have learned before the first step to find eigenvalue is to compute A minus lambda I, where lambda will be your eigenvalues later. Okay, so lambda I is the lambda multiplied by the identity matrix. So for 2 times 2 matrix, you will have lambda I equal to lambda 0, 0, lambda. So now you need to find what is A minus lambda I. So we have our A 2, 3, 4, 1 minus with lambda I, lambda 0, 0, lambda. Okay, so now what you will have here is 2 minus lambda will give you 2 minus lambda. Here 3 minus 0 is 3, 4 minus 0 is 4 and 1 minus lambda is 1 minus lambda. Okay, next step, the second step to find the eigenvalues is to find what is the determinant of A minus lambda I. Means that we need to find the determinant for matrix 2 minus lambda, 3, 4 and 1 minus lambda. Okay, and we have learned before how to find determinants for 2 times 2 matrix. You need to multiply these elements. Okay, so to find determinants, you need to multiply 2 minus lambda with 1 minus lambda minus with multiply this element. 4 multiplied by 3 will give you 12. Okay, so let's expand this equation. So we have here 2 times 1 will give you 2. 2 times negative lambda will give you negative 2 lambda. Negative lambda times 1 will give you negative lambda. Negative lambda times negative lambda will give you positive lambda square minus 12. Okay, so let's see which part we can simplify. So here you have your positive lambda square. So let's write it in front here, positive lambda square. Then we have negative 2 lambda minus lambda, that will give you negative 3 lambda. 2 minus with 12 will give you minus 10. Okay, next we need to find the lambda, where lambda is your eigenvalues. So how to find lambda? We will let the determinant of A minus lambda I equal to 0. So here is the value of determinant A minus lambda I. So we will let lambda square minus 3 lambda minus 10 equal to 0. So now you can factorize this equation. Either you want to factorize it manually or you want to factorize it by using calculator. Okay, you will get the value of lambda. So let's factorize it manually. You will get here lambda minus 5 times with lambda plus 2 equal to 0. Okay, therefore from here you will get your first value of lambda equal to 5 and the second value of lambda is equal to negative 2. So this one is your eigenvalues. So now we want to find the eigenvector that corresponding to both eigenvalues here. So we start with lambda equal to 5, where our eigenvalues is equal to 5. Okay, so the first thing you need to do is, again, you need to compute A minus lambda I. Okay, now you have your matrix A equal to 2, 3, 4, 1. Okay, and you know already the value of lambda, which is 5. Therefore, you will get minus with 5005. Okay, so your lambda is 5. So here is lambda I. So what you will get here is 2 minus 5 is negative 3. 3 minus 0 is 3. 4 minus 0 is 4. 1 minus 5 is negative 4. Okay. So now you have A minus lambda I. So how can you find the eigenvector for this matrix? Is by finding what is the value of x where you have A minus lambda I multiplied by x equal to 0. Okay, so now you have your matrix A minus lambda I here. So we have negative 3, 3, 4, negative 4 multiplied by the variable x. Let's put it as x1 and x2. Okay, because you have two column here, therefore you have two unknown equal to 0, 0. Okay, class. So now you want to find what is the value of x1 and x2 because that one will be your eigenvector. Okay, so to find the value of x1 and x2, we will use the knowledge in finding the solution to the system that we learned before. So the first step is to write this matrix in terms of augmented matrix. So you will have your augmented matrix negative 3, 3, 4, negative 4, 0, 0. Okay, so what you need to do here is you need to reduce this to row echelon form. Okay, so you need to reduce this matrix to row echelon form means that you need to make this element to become 1. So how? By dividing it with negative 3. So R1 is equal to R1 divide negative 3. So means that we are changing row number 1. Row number 2 remain the same. So you just need to copy back. Okay. Row number 1 divide by negative 3. So you have negative 3 divide negative 3, 1. 3 divide negative 3, negative 1. 0 divide negative 3 is 0. Okay. Next, how to get the row echelon form is by make sure this element will be equal to 0. So how can you make sure this element to be 0? You need to do row operation where R2 is equal to R2 minus 4 times R1. Okay, so you will change the value of R2, therefore R1 will remain the same, 1, negative 1, 0. So now 4 times R1, so 4 times 1 is 4, 4 minus 4 is 0. 4 times negative 1 is negative 4. Negative 4 minus negative 4 will give you 0. So 0 minus 0 will give you 0 as well. So now we already have our row echelon form. From this matrix, you can write your equation. So this one is x1, this one is for x2. So you will have x1 minus x2 is equal to 0. Okay, so how to solve the value of x1 and x2? If you can remember before this, we have learned about pivot and non-pivot column, where pivot column is the column that consists of leading one. So you have this one as a leading one. Therefore, this column we call as pivot column. And for this column, there is no leading one. So this column we call as non-pivot column. Okay. So the variable that belongs to pivot column, we call it as leading variable. So we have our leading variable x1. And the variable that belong to non-pivot column, we call it as free variable. This one we have learned before. So our free variable is x2. So in solving our system, we will let our free variable to be equal to t. So let x2 equal to t. Therefore, from here, you will have x1 minus t equal to 0. So your x1 is equal to t as well. Okay, so what is the value of x? X will be, your x1 is t and your x2 is t. So this is the eigenvector for lambda equal to 5. Okay, this is how you find eigenvector, where you just need to solve the solution to find what is the value of x1 and x2. Okay, and we will let the free variable to be equal to t. Okay, so now we want to continue to find what is the normal eigenvector. So if you can remember, to find normal eigenvector, we use the symbol U for normal eigenvector. Okay, so to find normal eigenvector ataupun simbolnya adalah U, formulanya adalah x divided by magnitude of x. Okay, so how to find magnitude of x? Square root x1 square plus x2 square. Okay, so let's find the magnitude x first. Okay, so square root, your x1 is t, so you have t square, plus your x2 is t as well, so you have t square. Therefore here you have square root of 2t square. You can separate it, it will become square root of 2 and square root of t square. So this one can be cancelled out. Okay, so what you left is the magnitude of x is equal to square root of 2t. Okay, so to find normal eigenvector, which is u, you just need to divide x with the magnitude of x. So your x1 is t, you divide by the magnitude of x, which is set to t. Okay, and your x2 as well is t, so t divided by your magnitude of x, which is set to t. Okay, so now you can see that t and t can be cancelled out. Therefore, your u will become 1 over set 2 and 1 over set 2 as well. So this one is called as normal eigenvector. Okay, you need to remember that all that we do just now is just for eigenvalue equal to 5. So we need to repeat the same thing to find what is the eigenvector and normal eigenvector when your eigenvalues is equal to -2. So we repeat the same process. Okay, the first thing is you need to compute what is your a minus lambda I. So now you already know your lambda is -2. Okay, so you will have a minus -2i. Okay, so you will have a plus 2i. Therefore, your matrix A is equal to 2, 3, 4, 1. Plus with 2i is 2, 0, 0, 2. Okay, so now you will have your a minus lambda I as 2 plus 2, 4. 3 plus 0 is 3. 4 plus 0 is 4. 1 plus 2 is 3. So this one is the matrix A minus lambda I. Okay, so what is the eigenvector? Okay, so you will have a minus lambda I times with the eigenvector x equal to 0. Okay, where your a minus lambda I is this matrix. So you will have 4, 4, 3, 3 multiplied by x. So you have 2 columns, therefore you have 2x. So let's put at x1 and x2. Okay, equal to 0, 0. So now what you want to do is you need to find the solution or the value of x1 and x2. So we will use the knowledge of solution to the system, where the first thing you need to do is you need to transform this matrix into augmented matrix. Okay, so what you will have here is 4, 4, 3, 3, 0, 0. So you need to reduce this matrix into row echelon form so that we can find the solution of x1 and x2. So to reduce this one to row echelon form, you need to make sure this one is equal to 1. So how to do? We will divide R1 is, we will divide R1 with 4. Okay, so what you will have is the same row number 2. So awak salin je balik, row number 2 ni sama. Row number 1 kita bahagi semua dengan 4. So apa yang awak akan ada kat sini adalah 1, 3/4 kosong. Next, apa yang kita kena buat adalah kita kena jadikan yang ini sebagai kosong. So operasi yang awak kena buat kepada row number 2 adalah row number 2 tolak dengan 4 row number 1. Okay, so row number 2 akan berubah tapi row number 1 akan kekal sama. So awak salin je balik. Okay, so 4 darab dengan row number 1. So 4 darab 1, 4. 4 tolak 4, kosong. Okay, 4 darab dengan 3/4 will give you 3. So 3 minus 3, kosong. Dan kat sini pun kosong. So now you already have your row echelon form. Okay, so from here you have your equation because this one is belong to x1 and this column is belong to x2. So awak akan di equation awak x1 plus 3/4 x2 is equal to 0. Okay, and remember that this one is the leading one, the leading coefficient. Okay, so this column is called as pivot column. And this column is called as non-pivot column because there is no leading one here. So the variable that belong to pivot column we call as leading variable. So our leading variable here is x1. And the variable that belong to the non-pivot column we call it as free variable. So free variable is equal to x2. Okay, so how to solve our solution? We will let the free variable to become t. So now our x2 is equal to t. Okay, when your x2 is equal to t, you just need to substitute here. So you have x1 plus 3/4 t equal to 0. x1 equal to negative 3/4 t. Okay, so now you already have your value of x1, the value of x2. So you can write your x as negative 3/4 t and t for x2. So this one is your eigenvector. So now let's proceed to find normal eigenvector. So the formula to find normal eigenvector, which is u, is the value of x divided by magnitude of x. Okay, and how to find magnitude of x? The formula is square root x1 square plus x2 square. Okay, so we have our x1 equal to negative 3/4 t. So negative 3/4 t square plus with x2 square. So plus with t square. So what we have here is negative 3/4 square is 9/16. T square plus t square. Okay, so you will have square root of 25/16 t square. Okay, so this one you can separate to be square root of 25/16 and square root of t square. So this one will be 5/4 t. Okay, means that the magnitude of x is 5/4 t. So to find the normal eigenvector, okay, you take the value of x1 divide by the magnitude. So negative 3/4 t divide by 5/4 t. Okay, and the value of x2 divide by the magnitude. So you have t divide by 5/4 t. Okay, so here you can cancel out. So what you will have here is u equal to negative 3/5 and 4/5. So this one is your normal eigenvector.